Alrighty. Hello, guys. Today we're going to talk about parallel and perpendicular lines. And this is where all of our skills come together. And we must use them to write parallel and perpendicular lines. Please remember that there are three forms of linear equations. The first form that we learned was the slope-intercept form. The reason it's called the slope-intercept form, think about it. They give you a slope, and they give you an intercept. I'm not trying to be funny, that's the way I always remember it. Slope, intercept. They give you a slope, they give you an intercept. That's the best method to use when you wanna graph, yes. You use the slope-intercept form when you want to graph. The point slope form, think about it. X1 and Y1 forms a point, and they give you a slope. So hence, point slope form, point slope. This is the best form you're going to use when you want to write linear equations, okay? You want to write linear equations, that's the form you use. And in the standard form, there's no trick with point or slope. It's just a standard form, ax plus by equals c. Please remember that a and b are 99% of the time going to be asked for you to put it in integer form. That means a and b can be both positive and or negative, but they have to be whole values. They cannot be fractions or decimals. Okay? And this standard form is the best way to find the x-intercepts and the y-intercept. That's what this is used for. And it's used for graphing when? Very good. You use it to graph when A and B are factors of C. So in other words, if A and B go in evenly into C, then that would be the best way to graph it, because you could find your y and x intercepts easily, plot the x and y intercept, connect the dots, you're done. Okay? Does that make sense? Okay. Awesome. Now, let's talk about parallel lines. Parallel lines, my friends, have equal slopes. Parallel lines will never intersect because their slopes are equal. If you notice this first equation here, this is y equals 3x plus 8. Over here, this is y equals 3x minus 4. The slope for both of them is 3. So since the slopes are equal, and check this out, the y-intercepts are different, they are parallel. What would happen if the slopes are equal and the y-intercepts are equal? It'd be the same line. Very good. And then in that case, there's infinitely many solutions because it's the same line, so all numbers work for that line. But parallel lines will have the same slope and different y-intercepts. That's what parallel lines are. Think of parallel lines like when you're driving on the highway. Let's say you're on the turnpike and you're going to Orlando, okay, and you're going north. If you look to your left, aren't there cars going south? Aren't those roads exactly next to each other, but they never intersect? Those roads are parallel. That's what parallel means. Okay? They're going in the same direction or opposite directions, doesn't matter, but the lines will never intersect. They will never intersect because the slopes are equal. Perpendicular lines. Perpendicular lines are lines that have slopes that are negative reciprocals of each other. I'm going to explain what that means in a second. Since their slopes are negative reciprocals of each other, the lines will intersect at one point and they are perpendicular. If you look here, I'm going to zoom in on this. If you look here, this little red block here that's going to be zoomed out, or maybe not. Let's try that again. Why is this not working? Why did that happen? Okay, let's try this again. Come on, magic pen. There we go. All right. See that little red box there? That little red box indicates that is a 90-degree angle. That indicates that it is a right angle. A right angle is an angle that has 90 degrees. When you have perpendicular lines, they're going to intersect at one point. And that point that they intersect at will create 90-degree angles, okay? So there's a 90 there, a 90 here, a 90 here, and a 90 here, okay? So that's how you know they're perpendicular. Now, what's this whole negative reciprocal jazz? Well, look at the slope of this guy. It's negative 1/3. The slope of the perpendicular line is 3. A negative reciprocal is found very easily. A negative reciprocal is found by multiplying by a -1, and then step 2, flip it. So guys, what's negative 1/3 times -1? 1/3. Flip it. 3. Done. So, when we're talking about negative reciprocals, you've got to know how to recognize it. So I'm going to have original slopes on the left, negative reciprocals on the right. If my original slope is 3, what's my negative reciprocal? Negative 1/3, because I multiplied by a negative and flipped. If my original slope is 2/5, what's my negative reciprocal? Negative 5/2, because I multiplied by a negative and I flipped. If my original slope is negative 1/5, what's my negative reciprocal? Positive 5/1, because you multiply by a negative and flip. Are you with me, guys? Okay. So that's how you recognize if lines are parallel or perpendicular. If they ask you, are these two lines parallel or perpendicular? Look at their slopes. If the slopes are equal and the y-intercepts are different, they're parallel. If the slopes are negative reciprocals of each other, then they are perpendicular. Yes, sir?
Why did you get the negative reciprocal first equation?
The negative reciprocal of negative 1/3 is 3. So this and this are negative reciprocals, so there is a perpendicular line. When the slopes are negative reciprocals of each other, the lines are perpendicular. Okay? Now, the rules. How to write equations for lines that are parallel or perpendicular to a given linear equation or graph going through a particular ordered pair x1, y1. These are the rules you're going to use regardless of if they're asking you for parallel or perpendicular. Step 1. Find the original slope of the given equation. So find the slope. Whether you have to look at a graph and count your rise over run, or if they already give it to you in slope-intercept form, or if they give you 2 points, you're going to have to find the original slope. Step 2. Find the parallel or perpendicular slope of the given equation, depending on what they're looking for. If they're looking for parallel equations, your parallel slope is equal to the original slope. If they're looking for perpendicular equations, your perpendicular slope is the negative reciprocal of the original slope. Then these last 2 steps you've been doing for 4 days now, 5 days. Plug in the given points into the standard, plug in the given points x1 and y1 and the new parallel or perpendicular slope into the point slope form. And then step 4, solve for y in slope-intercept form. And you're done. Okay? And you're done. So the only difference to what you have been doing is step 1 and 2. Got to find the original slope and then find if it's the parallel slope or the perpendicular slope, depending on what they ask. For example, write the equation of each line in the slope-intercept form, which is, it's parallel to this equation, and this parallel line is going through this point. Okay? So step 1, what is the original slope? 6. Excellent. Step 2, what is the parallel slope? 6. Now step 3, guys. This equation, that's it. We don't need to use it anymore. The only thing I needed from the original equation was the original slope. I don't care anything else about that. You with me? Now, y minus y1 equals the parallel slope, which is 6, because I already clearly noted it, times x minus 1. Now solve for y. Y plus 3 equals 6x minus 6. Subtract 3 to both sides. So my new parallel equation is y equals 6x minus 9. Same slope, different y-intercept. Super easy. I'm glad you see it that way, brother. Good. Does that make sense? Talk to me. Huh? You don't understand step 2. Aren't parallel slopes equal? So that's how you got step 2. Parallel slopes are equal. You got to find the original slope. If you're looking for a parallel line, the slopes are equal. If you're looking for a perpendicular line, the slopes are negative reciprocals of each other. For example, I want to find now a perpendicular line. It's perpendicular to this line, and it goes through this point. Step 1, what is the original slope? Negative 4. Step 2, what is the perpendicular slope? It's negative reciprocal, guys. So you multiply by negative 1, and then you flip it. To find a negative reciprocal, you multiply by negative 1, and then you flip it. So what is the perpendicular slope? 1/4. Now it's Mickey Mouse. Y minus y1 equals m times x minus x1. Y minus 5 equals 1/4 x minus 2. Add the 5. So my perpendicular line is y equals 1/4 x plus 3. It's perpendicular because the slopes are negative reciprocals of each other. Does that make sense, gentlemen? We're going to do 2 more examples now. Yes, sir.
Wait, is it going to be like that? For step 2, are you going to have to draw 2 lines to mean parallel and that?
Okay, what his question was, why did you draw 2 lines? Okay, I like to label things for myself. Here it was a parallel equation, so I said my parallel slope. These 2 lines means parallel. That way, I know what I'm looking at. In the bottom one, I use this symbol to define perpendicular. This symbol equals perpendicular. So, is it required for you to write that symbol down? No. But is it beneficial? Yes. Because if you do not show yourself what you're doing, we are all human beings. And you will falter more times than not. I've been doing this a long time, guys, and I always label. Does that make sense? All right. Give us 1 second, please. Okay, guys. So let's continue. Let's do a couple more examples. All right? Write the equation of each line in slope-intercept form, which is the first one, parallel to y equals 2x plus 3. So remember, the new line that we're creating is parallel to this one. And the new line that we're creating is going through those points. So step 1, what's my original slope? So original slope equals 2. Step 2, what's my parallel slope? Perfect. Step 3, a point slope form. Y minus y1 equals m times x minus x1. Solve for y. Y plus 1 equals 2x plus 6. Subtract 1 to both sides. My new parallel line to this guy is y equals 2x plus 5. You can check to make sure you did it correctly. Slopes are equal, and the y-intercepts are different. You're done. Does that make sense, guys? Let's check out the bottom one with perpendicular. Step 1, original slope. What's my original slope, my brothers? My original slope is 2/3. Okay, step 2, what's my perpendicular slope? Negative 3/2, because remember, negative reciprocal, you multiply by a negative and flip. Now you go y minus y1 equals m times x minus x1. Solve for y. So you distribute that 3/2 x. Now look, for this, guys, please, remember this is a 12/1. What's negative 3 times negative 12? Positive 36. And 2 times 1? So what's 36 divided by 2? So this is positive 18. Add 5 to both sides. y equals negative 3 halves x plus 23. The slopes are negative reciprocals of each other. Does that make sense, gentlemen? And it is, papita. It's very easy. Okay? All right. You with me, boys? Okay. So this is one skill that you definitely have to know. And now another skill is, sometimes they're just going to give you two random equations, and they're going to say, hey, are these parallel, are they perpendicular, or are they neither? And that's important too. For example, determine if the given equations are parallel, perpendicular, or neither. Let's just use our brains, guys. It's all about slopes, right? So what you want to do when they ask you these, convert both given equations to slope-intercept form. And then that way you could clearly isolate the slope and see if it's parallel, perpendicular, or neither. This guy's all solved for, but let's solve for this guy. So I'm going to divide by 4 to both sides. I get y equals negative 5/4 x plus 3. Are these parallel? No, because the slopes are not equal. Are they perpendicular? Yes, because the slopes are negative reciprocals, so this is a perpendicular line. These guys are perpendicular. If you were to graph these, they will intersect at one point, creating a 9-degree angle. Number 2, or B, this guy is already set up. Let's solve for y. Subtract 4x to both sides. So I got negative 3y equals negative 4x plus 9. Divide by negative 3. Y equals 4/3 x minus 3. Are they parallel? No, this is 3/4. That's 4/3. So they're not parallel. Are they perpendicular? Absolutely not. Perpendicular would have been negative 4/3. Guys, I know we just learned it today, but you better commit this to memory. In order for them to be perpendicular lines, the slopes must be negative reciprocals of each other. In order to find a negative reciprocal, you must multiply the original by a -1 and then flip it. If you were to take this 3/4, multiply by -1, that's negative 3/4, flip it, that's negative 4/3. That is not what you have here. So in this case, this would be neither. It's not parallel, and it's not perpendicular, so it's neither. Does that make sense? Okay. Next. Neither, well, this one's already solved. So I'm going to divide that by 6. So y equals negative 1/6 x plus 1, because remember, it distributes to both. So are these parallel? Yeah. Got negative 1/6, got negative 1/6. They're parallel. Does that make sense, gentlemen? Sir, my brother. Neither. I before E, except after C, and in words like neighbor and way. No, it's neither, and I believe I'm spelling it right. The rule in English is I before E, except after C, or in words like neighbor and way. That's how I remember. Okay, but anyways, it's not an English class. And we're good. Yes, sir. Is it EI? Okay. I thought that should work though. My rule does work though, but okay. No worries. It just doesn't. That doesn't look right. Okay, well, regardless, it's none. It's not parallel and it's not perpendicular, all right? Does that make sense? Okay, relax. So it's EI. Thank you. We're good? All right, my brothers. Homework is valid.